The day the Earth spun faster. Is today the shortest day ever? Today we ask what on earth is going on with Earth. Stay tuned. Have you noticed that today might actually be one of the shortest days ever recorded? Our planet is doing something strange. It's spinning faster than usual. In fact, today on July 9th, 2025, Earth's rotation is expected to finish about 1.3 milliseconds ahead of schedule. That's 1.3 thousandths of a second shaved off the normal 24-hour day. That makes today potentially the shortest day in modern history. So this may sound like science fiction, but it's absolutely true. Earth is turning on its axis just a tiny bit faster than usual. A millisecond is only 0.001 second, so that's far shorter than even a blink of an eye. A blink actually lasts about 100 milliseconds. So you and I are not going to feel this blink of an eye difference. But to scientists and to timekeepers, this is actually quite huge. Today's fleeting milliseconds are making headlines because they break records and puzzle experts. Why is our planet picking up the pace? And what is it going to mean for the rest of us? So let's unravel this little mystery. And we'll do it in terms that hopefully everybody can understand. So why could today be the shortest day ever? First, here's a surprising fact. Earth is almost, but not quite, a perfect timekeeper. We say a day is 24 hours or 86,400 seconds long, but in reality, Earth's rotational length wiggles by a millisecond or two day to day. Sometimes the day is a hair over the 24 hours, sometimes it's a little bit under. Now, we only discovered these tiny fluctuations when we invented ultra-precise atomic clocks way back in the 1950s. These clocks show that our planet's spin isn't as steady or as perfect as we think it is. It varies, and that's due to a variety of fascinating factors. Now, over Earth's 4.5 billion year existence, the length of a day has actually changed dramatically. Hundreds of millions of years ago, in the age of early life, Earth spun so fast that a day was only 22 hours long. Now, scientists were able to figure this out from ancient coral fossils. They grew daily layers, but like tree rings, and over geological time, Earth's rotation has slowed down, and that's mainly due to the Earth's gravitational pull putting the brakes on us. As the moon's pull raises our tides and gradually steals Earth's rotational energy, our day has lengthened by about 1.8 milliseconds per century. So, in fact, looking forward into the far future, days could even stretch to over 24 hours in length. But that's not going to happen for at least 200 million years. So yes, on average, Earth's rotation is slowing over millennia. That's why timekeepers occasionally add a leap second to our clocks. And 27 leap seconds have actually been added since 1972. And that's to sync them with Earth's gradually longer days. But if that's the case, what's going on? And this is the twist. Recently, Earth started speeding up again. Since 2020, we've actually measured several record short days each year. It's like Earth hit the gas pedal when we expected it to be hitting the brake. Now, one scientist, Leonid Sotov, has admitted that nobody was expecting this. The usual models, factors like ocean tides and atmosphere, don't explain this huge acceleration, he says. So in other words, something unusual is happening beneath our feet. And it really is a blink and you'll miss it moment. Let's look at some of the shortest days we've had already on record. And as I mentioned, a lot of these has happened since 2020. Now, until 2020, the shortest day ever observed with atomic clocks was 1.05 milliseconds under 24 hours. But since then, Earth has actually broken that record every year. 2020 had days 1.47 milliseconds short. 2022 saw a day that was 1.59 milliseconds short. Now the current champion is July 5th, 2024, when Earth's rotation was 1.66 milliseconds faster than a standard day. That's the fastest spin on record so far. That's a record that we actually might challenge today. Scientists have predicted that around July 9th, 2025, today, Earth would again come within 1.3 milliseconds of that record. And it may not actually stop there. Later this summer, on July 22nd, possibly we could be 1.38 milliseconds shorter, and August 5th, we could be up to 1.5 milliseconds shorter than the average day. So what we're witnessing is actually 3 of the shortest days ever recorded in modern history, and that's all happening within a matter of months. Now, in the great scheme of things, these millisecond shavings might seem quite trivial, but for scientists, this is like an Olympic sprint where Earth keeps beating its own personal best. It's quite fascinating and also quite baffling. So what on earth is going on with Earth to cause the planet to spin faster? Now we need to start by exploring just how Earth's rotation can speed up or slow down in the first place. Now, if you like to think of Earth as a giant spinning top, its rotation can speed up or slow down if its mass distribution changes or some outside force acts on it. Now, a great analogy is a figure skater. When you watch a figure skater and they pull in their arms, they will actually spin faster, and when they extend their arms out, they will actually spin slower. And the Earth is very similar. If mass moves closer to the Earth's center, it can spin up. If mass moves outward, it will actually cause the planet to slow down. And there's a number of things that can cause these type of shifts. There's tidal forces. We have the moon's gravity being a major player in this. Over long times, the moon's tug is slowly slowing Earth. It's a bit like the skater with their arms out. But even on a short time scale, the moon can affect rotation. When the moon's orbit aligns in a certain way, it can actually reduce drag or friction on Earth's rotation. For example, Earth actually spins a little bit quicker when the moon's path is far north or south of the Earth's equator. And right now, these record short days, they're actually happening when the moon is at its maximum distance from the equator. So that actually minimizes tidal drag, and it's a bit like giving Earth a momentary spin boost. There's also things like seismic activity, earthquakes. So massive earthquakes can actually jolt Earth's mass inward. A powerful quake in Japan in 2011 actually sped up Earth's rotation enough to shorten a day by about 1.8 microseconds. Now that's tiny, but it shows what's the principle and the effect that these type of events can have. When the Earth cross shifts during a quake, it's like a skater pulling in their arms. The spin speeds up slightly. Now, a little fun fact here for free. The closer that to the equator that the mass shifts, then the more it speeds Earth up. Now, there is something called glacial rebound. That's when Earth's shape is still adjusting from the last ice age. The large ice sheets press down land masses, and now that ice is melted, the land is rising back up, albeit slowly, and this is called glacial rebound. And as heavy ice melts and water redistributes itself towards the oceans, Earth mass shifts slightly again. Land lifting upward, that's mass moving outward from the center, can slow the spin, whereas ocean mass spreading or moving inward could speed it up. It's a slow process, but over decades and centuries it does contribute to rotational changes. And what about atmosphere and ocean dynamics? Shifts in air and water can also change the spin rate. Winds, ocean currents, and even seasonal weather patterns move mass around. For instance, as the jet stream shifts seasonally, the length of days naturally oscillates by up to 1 millisecond over the year. Think of massive air currents or ocean water slushing. When more mass moves towards the centre, then Earth spins up a bit faster. When mass moves outward, such as warm air expanding, it spins slower. We have seasonal changes, El Nino events, and big pressure systems that tug imperceptibly on Earth's rotation. And of course we have internal core dynamics. Now this is a mystery within itself, because we know some things but we don't know everything about what actually happens in the core of our planet. Deep in Earth's interior, the liquid outer core and solid inner core can rotate slightly differently from the mantle and the crust above. Now there's evidence that the inner core's rotation speeds up and slows down on a roughly 60 to 70 year cycle, and it might have even paused or even reversed direction relative to the surface in the last decade. So could changes in the Earth's core and its rotation be transferring momentum to the rest of the planet? Some scientists think yes. The recent speed up might have roots in the core. Dr. Sothoff and colleagues, for example, suspect that some process in Earth's depths is actually influencing the spin. Essentially, the core might be doing its own dance, subtly pulling the rest of Earth around with it, and through gravitational and magnetic interactions. Now we're still trying to figure this out, but it's intriguing that the Earth's magnetic field and its rotation changes seem to sync up with that inner core cycle. So in short, Earth's rotation is a complex ballet of many factors. There's the tug of the moon, shifting winds and seas, a rebounding crust, the churning core, and even the occasional earthquake. Now usually these factors balance out or cause only slight drifts, but right now many scientists believe that something extra is tipping the balance towards a faster spin. Now the tricky part and the unfortunate part for the rest of us, no one is actually 100% sure what that something is yet. It's certainly an active area of research, and one of the questions is why now? Why has things started to speed up a bit since the 2020s? Why have we seen these unusually short days in the last 5 years? Now scientists are on the case. Some clues point to short-term wobbling motions of Earth. In 2022, when the then record day was recorded, researchers also noted an intriguing coincidence. Earth's axis wobbled slightly in an oscillation called the Chandler wobble, and it was unusually small at the time. One theory is that this reduced wobble helped spin Earth a tad faster. Like a top standing more upright, spins faster than a wobbly top. Now it's still just a theory, but it shows how even a subtle polar wobble could affect the timing of Earth's rotation. Now others, like Dr. Sothoff, lean toward more internal causes. He went on to say that ocean and atmospheric models don't explain this huge acceleration. In a 2022 study he co-authored, he examined Earth's rotation and found nothing in the usual external factors that fully accounts for the speed up. This has led to speculation that changes in the Earth's core or its mantle, like altered flows in the molten outer core or interactions between the core and the mantle, might actually be contributing to the rotational speed of the Earth. Now of course this is a tough nut to crack because we can't observe the core directly. We have to infer its behaviour from like the seismic waves and magnetic data. But the timing is suggestive because some data does indicate that the Earth's core rotation slowed down around 2009 to 2011, after speeding up for decades. So that's possibly part of that 70-year cycle. If the core slowed relative to the crust, conservation of momentum could speed up the crust ever so slightly, and that's perhaps part of what we're seeing now. So all this shows is probably the beauty of science. It's not even something as routine as the Earth's rotation can still surprise us. With everything we know, there's still a lot we don't know. So we're essentially detectives of time, piecing together clues from the oceans, from the skies, and from deep within the Earth to solve this riddle. Meanwhile, another team of scientists point out the role of climate change in Earth's rotation, but in the opposite direction. NASA researchers reported in 2024 that melting ice sheets and changing groundwater are actually lengthening the day by about 1.33 milliseconds per century by shifting mass towards the equator. And that is a slow effect that will actually make days longer over decades and centuries. So it's a bit ironic. Human-driven changes are nudging the Earth to spin slower in the long haul, while some natural variations right now are actually making the Earth spin faster. These are opposing influences and they complicate the picture further. So in essence, Earth's rotation has a lot of dials on it, and there's knobs and switches all controlling it. And at the moment, nature has flicked that faster switch and it's turning up that dial just a little bit, and we're waiting to see when it's going to turn things back down. The likes of Dr. Sothoff suspects we may be near the peak of the speed up, hinting that sooner or later Earth is going to slow back to its normal routine. And does it really matter? What does a millisecond count for? So you might wonder, well, what if the day is 1.5 milliseconds shorter? It's not like the sun is rising any noticeably earlier or setting any noticeably sooner. And that's true for everyday life. You and I are not going to notice any of it. The clocks on our walls won't suddenly go out of sync. However, these minuscule time shifts do matter when you're particularly dealing with high-tech arenas and things that are time sensitive. For instance, the official global time standard, Coordinated Universal Time, UTC, that's tied to Earth's rotation. So when Earth was consistently slowing, scientists added leap seconds now and then. And that was usually added on New Year's Eve or mid-year to keep our atomic clocks match with Earth's actual day length. So in fact, if this faster spin continues, experts predict that we might have to do something unprecedented and actually remove a second from the clock. By one estimate, if the trend persists, a negative leap second may be needed by 2029, which means we'd actually subtract a second from UTC time, and it would enable us to catch back up with Earth's rotation. It would be the first time ever we've had to do that. And this possibility has timekeepers both excited and a wee bit nervous. And there's also things like navigational systems like GPS or telecom networks, financial trading platforms, all rely on ultra precise timing. GPS, for example, needs to account for Earth's rotation to be able to pinpoint locations. So if Earth's rotation drifts, even by a few milliseconds, and time standards aren't adjusted, it could introduce errors. So the next time you check your watch, or check the time on your phone, or have a look at the clock on the wall, remember that it's just not a machine in sync with itself. It's in sync with a cosmic dance of Earth, and today it's going to be 1.4 milliseconds of a difference. One thing's for sure, our Earth is very much alive with motion, from the tectonic plates deep below our feet to the atmosphere above, and even in how it spins on its own axis. It's a dramatic reminder that nothing in nature stands still, not even time itself. So, cherish this record-breaking day. Something to tell your kids and grandkids you were there on the shortest day ever, even if it is just for a few milliseconds less. and keep watching the clocks, because who knows what surprises the Earth will spin up next. So stay curious, and until the next time, enjoy every millisecond of your day, no matter how short it is.